do distributive property first. So these are sample problems you should be able to do on your test. Some with pictures, some with like expanded and factored form. All right, so Haley, if you had to write two different expressions for number one here, what's one that you could come up with? The area model. So yeah, so this little rectangle here, for example, if you just look at this as a rectangle itself, that one right there, there's a white one, and then let's say we put this green one. You could think of it as the area of two different rectangles, and or you could think of it as just, and that didn't do that. Did I not have it selected? Kind of as two separate rectangles, or just that full white rectangle here. So you're right, this rectangle here would be 20 times x. So we just write it as 20x. If you could put the dot, if it helps you. And then this would be what, Haley? 6x, right? And if you were trying to find the area of the entire rectangle, you would add them together. So one way to write this is 20x plus 6x. So that's method one. Yeah, so what's another method?
You could do x and then, for that one?
Nope,
Okay.
just making room.
You could do x parentheses 20 plus 6.
Right, because the x is being distributed to both the 20 and the 6. Or if you look at it here, it's common to both. So this right here, the one that Haley did, is the factored form. I mean the expanded form, sorry. My brain is not, it's this expanded form right here. Because it doesn't have the parentheses. Right here. And then what Soham just said, the x with the 20 plus 6, that's the factored form. Right there. They both work. You can't really tell on that one. Why is that? When you ask, what, do they both work? Why is it harder to tell? What makes it harder to see if they both work? Like compared to the problem over here, Alex. Yeah, what makes it harder? Why would some of us not be convinced that these are both the same? Emily. Because it has an X, right? So you don't really get a good feel that they're the same. But they are the same. But over here there's no X. So Emily, what's this in this new one? Wow, the kids are just like slamming the blockers out there. Yeah. So let's do the second problem here. What do you get here, Emily, in the top rectangle? Do you want to do the factored form first? That's fine, 30. And then 4 plus 9. So what about the area of the top rectangle? How would you figure that out? 30 times 4, right? (30 times 9, right? So the expanded form is 30 times 4 plus 30 times 9. On this one, I could, let's make a little more room here. I could even calculate the value of the left side and the right side using order of operations. So this is parentheses first, so this is 13 and 30. And 30 times 13, what's 30 times 10?
300.
And then 30 times 3?
90.
So this is
390.
390. And now order of operations on the right side says do 30 times 4 first, because multiplication becomes before the addition. So 120 plus 30 times 9, 270. And when I add 120 and 270, I get 390. So it does work both ways. It's just on this second problem, because there's no variable like x, you can really believe it works. But eventually, you start doing lots of algebra, so you want to be comfortable doing it with the x. Does that make sense, Alex?
Mm-hmm.
So you have to be able to do both. One with, one without. Okay. So let's look at these down here. Which one, so let's make this problem 3, 4, 5, and then I added this new one in here. Of problems 3 through 6, which ones can you get a final number answer? Yeah, Tyson.
3, 4, and 6.
You guys agree? Because there's no variable, okay? So if we read the directions for each problem, use the distributive property, there's supposed to be a y there, to write an equivalent expression. So first you're going to just do the distributive property, okay? If the expression is in expanded form, my typing has something to be desired here, write it in factored form. If the expression is in factored form, write it in expanded form. And then if you want to check your work, you can figure out the answer to both parts for 3 of them. So this is in factored form, number 3, because it has parentheses. So I'm going to do expanded form. Okay, so Carrie, can you help me with that? There's a negative here. It's hard to see in the classroom. I think it shows up better on worksheets. Yeah, so if you thought about it as a rectangle, that's not a bad way to do that at all, except for there's a negative number. It's kind of weird, but you could still do it, right? This would be your 5 and your negative 6. And your negative 3 on the side. You could think of it that way. So that could help you get the expanded form. What would it be? Okay, so expanded form would actually show the steps. So you would really, negative 21. So you did the whole thing in your head? Okay. So really expanded form is, what did we do up there? It'd be like negative 3 times 5. Yes, plus negative 3 times negative 6. That's a 6, even though it didn't look like it. So, in other words, you do this times the first term, negative 3 times 5, and then you have the same operation, so plus negative 3 times negative 6. That's the answer. That's the whole thing that's being asked. That's where you stop. Because it's asking you not to solve it, but to write an equivalent expression that shows the distributive property. Do you get that? Tyson?
So when it says equivalent expression, you don't have to do the answer?
You don't have to do the answer.
Okay.
So what would be the equivalent expression for number 4, Ben?
Well, I didn't really get number 4.
Okay, so think about the rectangle. How would you put all of that on a rectangle?
Well, when you put like subtraction on one.
Yeah, okay, so I get that. It looks a little, I agree, it's a little weird to think of that with a subtraction problem. So did you see how I did these little arcs up here? Can you think of that? Like what was, when you looked at my result of the last problem, I ended up in the expanded form, but if you look at going backwards, what's common to both here is the -3. So in factored form, whatever is common to both is going to be outside the parentheses. So what's common to both in number 4?
6.
So 6 is common to both. I like to circle it. It helps me focus. So I put the 6 here. And then Emily, I'll be right with you. What's left inside?
2 minus 6.
No, because we factored the 6 out.
Oh, 2 minus -7.
Exactly. Emily? Never mind. So that's the whole answer, because all I'm asking you to do is use the distributive property to write an equivalent expression. Yeah, Kalis.
Shouldn't it be though, or I guess it doesn't have to, but like brackets, and then the parentheses around the -7, because it's.
You could write it a different way. You could do this. I find for me, I don't like that as much for me, but I don't have any trouble reading it, so if you like it better, you could use that. Especially if your negatives and get sloppy. Sure, if both are correct. Okay, so Emerson, how about number 5? So this is kind of like what I would call the rainbow here. The 6 came out, right? So if you think about it, the 6 gets distributed in. To check your work, 6 times 2 gave me this term, right? And then 6 times -7 gave me that term. So the 6 was out. And see how I did that rainbow up here? So what would you do with number 5?
You do 4x.
Yeah, perfect. 4x. So 4x. Same operation. Minus 4 times 5. That's expanded form. Tyson.
I know this isn't on topic, but how would you get the answer for it? Like, what would you?
Yeah, why would you do this?
How would you get the answer for it? Like,
Well, it's a great question. More next year than this year. You have a lot of things that you put in factored form to find solutions to problems. And usually the solutions vary, so they put a variable in. So it's so hard because you don't really have the background to understand it yet. But if you leave it in variable form, then I could say, what happens if x is 2? You could get me the answer. What happens if x is 7? You could get me the answer. You just keep changing x. But that's not the best answer. The best answer is, it wouldn't make any sense yet because you don't have any examples of where this applies. It's kind of like the alphabet. You know, like in kindergarten, you guys probably thought you were doing the alphabet. You did that song over and over. You do all these different things for the alphabet, but the alphabet alone is kind of useless, right? You're doing the songs just to keep you interested and to learn the alphabet, right? But there's no point in the alphabet until you learn to what? Write and read, right? Usually you read before you write. It's kind of like this. You have to learn the variable, the way to work with variables before you can see the point to them. So your book does a great job of showing purpose, but this one, not so much yet, because you don't have enough math to really see where it applies.
Okay.
But you will this year, and you'll see it a lot more next year, and then the rest of you take the time to take math. Okay, so want to try the next one, Cole? What do we have?
So, wouldn't it be?
Oh, this is supposed to be, there's a typo there. I made this right before you guys came in, which is why there's all these little typos. How's that? It's common to both, right? So 3.5
Times 15 minus 5.
times 15 minus 5. Now, if you wanted to check your work, you could, right? You could figure out 3.5 times 15 and add it to, or subtract 3.5 times 5. And then you could check it on this side. But what's the other purpose of distributive property is this problem on the left is kind of hard. If you factor it out, it's way easier, isn't it?
Yeah.
It's just 3.5 times what?
10.
Right, so if I asked you to find the value of a problem that looked like this, you could always just say, well, I think of it like this and work it out. That's what I would do, use it. You know, so maybe one of the test questions would be evaluate. And I'd give you that, and I wouldn't tell you anything else. Maybe then you should think about, wow, is there an easy way to do this?
Wait, what's like evaluate?
It means find the answer.
Oh, okay.
The word evaluate just means find the answer. So wouldn't it be easier than doing all of that to just do this over here? Because what's 3 times 10?
30.
And what's half of 10?
5.
So what's 3.5 times 10?
35.
Way easier. I didn't even write anything down except for this right here. This is a lot harder, isn't it? We'd have a lot of stuff to do. A lot of stuff. Still could do it, but you could save yourself probably 4 minutes on the test. So maybe part of it is just evaluate, and you have to think about how to do that. Okay, ready to do the next stuff? Okay. So summative practice, that's what these are. Jesse passes the 0 point running 10 meters per second to the right. Okay, here he is. Okay, where will he be 6 seconds later? So it's just his rate. What's his rate, Quinn?
Is rate?
Yeah, how fast is he running?
10 meters per second.
Uh-huh. So what'd you get for your answer?
60.
Right, because you're doing 10 meters per second times 6 seconds. Did you guys notice, I wonder, if you write out the units, just like multiplying fractions, you could cancel. You end up with 60, and what units are left?
Meters.
Meters.
Yeah, I didn't notice that.
Yeah, you want to start noticing that, because as you get advanced in science, you rely on that. Wait till you get to chemistry. Your whole life in chemistry is canceling units. Trust me on that one. Advanced math next year, dimensional analysis, same thing. Or advanced science. Okay, so now Jesse passes the 0 point. Maybe that 0 point will be like a location in some map when you take the test. And he's running to the left, right? So where will he be in 4 seconds later? So let's assume he's running at the same speed. He's running to the left. Okay, he passes the 0 running point to the left. Where will he be 4 seconds? Or 8 meters per second. Sorry, can't even read my own work there. Where will he be 4 seconds later?
You would be at negative 30, the negative 32 mark.
Right, because he's running to the left, so we're going to say he's running left with the negative 8 meters per second. And in 4 seconds from now, we want to know where he's going to be. So 4 seconds from now is in the future, so it's positive. So we get negative 32 meters, so he'll be 32 meters to the left of 0. there a question over on that side of the room? I thought I saw somebody saying that. No? Okay. Now Jesse's running, so he got a little tired and now he's getting energy back. He's now going to the right of second wind, 9 meters per second. Okay. Passes the 0 running point. Okay, where was he 3 seconds earlier? Alex.
27 meters.
How are you going to show me your work on your test? He's running to the right, so it's,
It's positive.
so is it a positive 9 meters because he's going to the right, or is it a negative 9 meters per second?
Positive.
Yeah, but we want to know where was he 3 seconds earlier,
So you would times it by -3.
because it's in the past, right? 3 seconds earlier is a negative. If I ask you a question like this, I'd like to see, I will be looking for your negatives and positives to be in the right place. Okay, so negative 27, so what does that mean?
It means he was
3 seconds earlier, where was Jesse?
he was 27 meters to the left.
Was 27 meters left of 0. Good job. Good job. Okay. Jesse passes a 0. I think we get this, right?
Yeah.
Okay. Let's do. Do we need to do one more? We have time to do this last one. Okay. So Jesse passes the 0 running point, running 11 meters per second to the right. Okay, so he's running to the right. Where will he be 3 seconds later? Emily? And it's positive because he's going to the right, correct? Times 3 seconds, right? And so you have 33 meters. So in a sentence,
3 seconds later, he will be at the right.
okay, 3 seconds later, he will be 33 meters to the right of 0, right? So what's the sentence for this? You already know. Have you ever gotten one right? I think you got them now, right?
Yeah.
So let's somebody who's never gotten one right that's ready, or that I haven't heard from, that hasn't done these. So, hey, Grace, what's your sentence? Yeah, Jesse is running past the 0 running point, right? To the left at 4 meters per second. What's the question now? So this is the situation, right? That's Jesse's situation. What's the question? A little louder. Right, where was he 12 seconds ago? Get it? Definitely going to see things like that on your test. You're also going to see money problems, right? Think of the section 4.3, the trail mix problems, the water tank problem, a chart, being able to read a chart. I'm just going to save this, Kyle, and then I'll take your question.
Yes.